Hello and welcome, I'm your Code Monkey. In this lecture we're going to add a visual to our selected counter, and in doing so we're also going to learn about the very useful singleton pattern. Okay, so over here we already have the logic to identify the counter in front of the player, and we can interact with it. However, whilst the logic works, there is no visual indicator at all, so let's add that. Now, as usual, the super quick and dirty way of doing it would be pretty simple. Over here on the player script, we could just directly enable a visual mesh on the target counter. So down here on the handle interaction, when we have this, over here we could tell the clear counter to enable some kind of visual. Technically that would work, but that would be some pretty dirty code. We would basically be making the player responsible for enabling some kind of visual, which would mean that we were mixing logic with visuals. Again, we always want to try separating the logic from the visuals as much as possible to keep our code nice and organized. So instead of doing the quick and dirty route, let's do it properly. Back in the editor, let's create a brand new C# script. Call this the selected counter visual. And now let's go into the prefab. Again, let's go inside it. So let's select the clear counter on the hierarchy. Then on the inspector, let's open up, go inside the prefab. And now let's select the visual inside it and let's duplicate this. So you can press Ctrl D to duplicate it. Let's name this one selected. And then inside there's a visual with a mesh filter and a mesh render. So over here, let's swap out the material. So let's click on the circle icon. And now included in the assets is this material, counter selected. So it's all the way, up here, the counter selected. Basically, it's just a solid white color with a low alpha. So on the kitchen counter inside the select game object, let's make sure to use this one. With this, we have kind of like a ghost visual. So if we enable and disable this game object, we can see the difference. Also, let's do one tiny thing, which is right now we duplicated the actual visual, meaning that these objects are exactly the same. They have the exact same size. And when that happens, you might end up with some rendering bugs. If two meshes are on the exact same position, you might sometimes see the colors constantly flip back and forth. So in order to make sure that doesn't happen, let's make this one, the selected, a tiny bit bigger. So over here with the selected game object selected, on the inspector over here we've got the scale, and also we've got this nice little button here. If it's like this, then we can modify each proportion differently from one another. Whereas if we click, now these are all linked. So now modifying one will modify all of them, so let's put this on 1.01. Meaning this one is going to be literally just 1% bigger. So that's enough of a difference to make sure we don't have any rendering bugs. And by default, let's also start with the visual hidden. So let's do that not on the parent select game object, but rather on the kitchen counter inside of it. Let's make sure to disable this game object. By the way, the quick shortcut is Shift, Alt, and A. You can enable or disable the object, very useful. So let's start with this one disabled so that it's hidden. And basically the goal is that when this counter is selected, we're going to enable it and show this visual, and when it's not selected, we're going to disable it. Okay, so over here on the selected, let's add the script that we made, so the selected counter visual. All right, so let's open it. Now here, first thing we need to know is which counter is selected. Meaning we need to know which counter the player is currently looking at. So let's go over here onto the player script, and let's basically just do some simple logic to keep track of the selected counter. So over here, let's make a field, so a private. Let's make it of type clear counter and just call it the selected counter. Then down here we have our handle interactions logic. Okay, so we do all of this. We try to find a counter in front, and if we do find it, then we have it here. So here let's just check if it's different. So if this clear counter, if the one in front is different from the current selected, then let's set the selected to this one. And let's also make sure to essentially unselect. So we want to make sure to set this one to null when there's nothing in front of the player. So if the raycast does not hit anything, then there's nothing in front of the player. So let's set the selected counter back into null. And also if there is something, but that something does not have the clear counter script, then it's also not a counter. So over here, let's also do an else selected counter equals null. So basically if there's a counter in front of the player, then it's going to set it. If not, then it's going to be null. Let's just do a simple debug.log to check on the selected counter. Okay. And also, just briefly, now that we've made this selected counter logic, actually up here when we have our interact action, like we saw, we were previously copying some duplicated code, but now we no longer need this since we already know the selected counter. So over here when we've got the interact action, let's just check if we do have a selected counter. So if it is not null, if so, then we go there and we call the interact function. So that's it, we no longer need all of this logic. Okay, that's great, so let's test. Back in the editor, let's go back into scenes. Let's make sure to save the prefab. Make sure the script was attached, save it, and let's hit on play. And right now, if I'm down here, yep, there you go, we've got null. And as I approach, yep, there you go, that one is a clear counter. And if I move towards this one, yep, it's that one. Okay, so basically we are keeping track of the currently selected counter. Now, basically, we just need to notify the visual whenever this one changes. So when this one is pointing at that one, or pointing at null, or pointing at that one, we need to know when that happens. And for that, we basically have two options. Now, one option is pretty much what I mentioned a while ago, which is over here we have the selected counter, so we can run some kind of logic on the selected counter. We can do that over here on the player. Then perhaps over here the counter would fire off some kind of event saying it has been selected, and then the counter visual would listen to that event and update itself. Now that approach would be useful if we wanted to add some kind of logic on the clear counter while selected, and that approach would also have the benefit where the visual counter would only listen to events on its own counter. So that's one approach, pretty much a very direct approach. But another one is very simple. The player would simply fire off an event whenever the selected counter changes, and then all of the counter visuals would listen to that event, then they would identify if the event relates to that counter, and if so, update their state. Now the benefit of this approach is that the logic doesn't get bothered with any selection logic. So over here the clear counter script never really knows if it's selected or not, and that's a good thing because it doesn't need to know. Although the potential con with that approach is that all of these selected counter visuals are all going to listen to the same event. So both approaches have pros and cons. Here let's go with the second approach where all the counters listen to a player event. The potential performance con doesn't really matter on a game of this scale. We're only going to have about a dozen counters, so even if 11 of them are just wasting on listening to the event, it's really not going to matter. And going with this approach will actually help us learn about the singleton pattern, which is extremely useful. So first let's go over here onto the player class and let's make the event that we're going to fire. So as usual, let's make it public so we can access it. Let's make it an event. And as usual, let's also use the standard event handler. Let's make sure to add using system. So here Visual Studio adds it automatically. Okay. And let's call this on selected counter changed. Also, this is a great moment to learn about the event args. This is how you can extend a C# event in order to pass in some more data. So how you do it by following the C# standard is very simple. We just create a class. So over here, let's make a public class. Then for the name, usually you include the name of the event with event args at the end. So in this case, on selected counter changed, and then event args. Then on this class, we make it extend event args. And finally, inside the class, we add whatever data we want. Like for example, we want the current selected counter. So let's make a public clear counter and put the selected counter. Okay, so we have this nice event args with a bunch of extra data, and then over here on the event handler, we use the version that takes a generic and we pass in our event args. Again, I covered the generics in more detail in a separate video. Definitely go watch that one if you haven't seen it yet. C# generics are one of C#'s most powerful features. Okay, great, so we now have our nice event. Now let's fire it off. So let's go down here to when we're modifying the selected counter. So here it is, we've got all of these ones. So when we modify, let's fire off the event. So we go into this event, and as usual, let's use the question mark and then call invoke. Then for the object sender, it's going to be this, so pretty much the standard. And then for our custom event args, let's construct an object of that type. So construct a new object. And then inside we pass in the selected counter and we set it to this selected counter. Now don't be confused by the fact that we're using the exact same name. If you actually mouse over the cursor, Visual Studio actually helps you by telling you which object refers to this. So with the cursor here, note how all of these are highlighted, but this one is not highlighted. That's because this is the field inside the onSelected counter changed event args, whereas this one out here is the object that we're referencing in here. So even though these two have the exact same name, here we're accessing the field inside of that, and we're assigning it to the reference that we have down here. Okay, so that's really it. We're firing off the event when the selected changes, and we're passing it in. And let's also make sure to do it over here, so let's copy and paste some code, and there you go, just like this. Except, of course, we can already see a bunch of code duplication. Usually that means it's time to refactor, so let's do that pretty quickly. Let's go down and make a brand new function. So let's make a private void. Let's call it set selected counter. And we're going to receive a clear counter for the selected counter. Then over here, we just set this dot selected counter. So we're modifying the member variable with the one that we receive on the parameter. And then let's also fire off the event. So let's copy paste the event just like this, the exact same thing. Okay, so that's it. And now up there, instead of code duplication, we just do this. So over here we set the clear counter, just call the function, pass in that one and get rid of this. And on that one, just pass in null, just like this, get rid of all of this. And here the same thing, just pass in null. All right, so with this, our code is much cleaner and everything still works exactly the same. So here we have everything done on the player side. Let's just get rid of our log, we no longer need this. So we're still handling the selected counter logic, and then down here we're firing off the event. Now all we need to do is go over here into the selected counter visual script. And here what we want to do is to listen to that event. And in order to do that, we need a reference to the player object. Now, so far, when we've been listening to events, like for example on the player class, up here we were listening to some events on the game input, so there you go, the onInteract action. So for the game input reference, we just added it as a serialized field. We did this and then we dragged the reference directly. And technically we could do the same thing over here on the selected counter visual, but we're going to have like a dozen counters in our map, so it would be pretty tedious to drag and drop the player reference to every single one of them. So instead of using a serialized field, another approach is to use the singleton pattern. This one is an extremely useful programming pattern. It's very useful for things where you only have one instance of something. In this case, we're making this game single player, so we're only ever going to have a single player. By the way, here's one obvious quick note. Like I mentioned in the beginning of this course, after this video, there's going to be another one converting this game into multiplayer, and in that case, we will have multiple player instances. But this is also an excellent reminder of how refactoring code is perfectly fine. For right now, for this game, it is intended as single player, so for now we're going to use the singleton pattern. Then in the future, when we convert this to multiplayer, we will simply refactor that logic. Again, don't be afraid of refactoring code. It's a perfectly natural part of programming and game development. Okay, so let's implement the singleton pattern. This is actually super simple. The name sounds intimidating, but it really is very simple. Over here on the player script, let's make a public field. This one, let's make it static. If you don't know static, basically it means that this field belongs to the player class itself and not to any instance of a player. So for example, if you had 100 players, you would have 100 instances of move speed, you would have one for each player, but there would only be a single static field because this static field belongs to the class itself and not to any instance. So let's make a field of type player, and then for the name, the convention is to call it instance. And the reason why I'm using Pascal case here, so capitalized in the beginning, the reason for that is because this is actually not going to be a field, but instead it's going to be a property. Remember the naming rules that we covered in the beginning of this course. It's very important you follow your naming rules. Always be consistent so your code is easier to understand. So with that said, since this is the first time we're using a property, let me quickly explain what it is. Basically, it's the exact same thing as a regular variable, except you can add some logic when getting and setting that field. So here, let me write some quick code just to show the difference between a property and a regular field. So for a regular field, you would call this maybe instance field, something like this. So this is a regular field. Then you would have some kind of public static return a player and call it get instance field. Then over here, you would return the instance field. And then maybe another public static void set instance field, where you receive a player for the instance field. And you would set the player.instance field into this instance field. So this is how you do this logic with fields. And now with properties, you would do public static player, then call it instance. Then on the property itself, you open up the curly brackets. Inside the property, you put a get, then you return something. So for that something, usually a property has a field underneath it. So you'd have a private static player for the instance. That's a different name from this one. On the get, you would return that. And on the set, you would set the instance equals the value. If you're confused here, don't worry. Basically, I'm just repeating just so you can see the difference. Here we have a field with a get and a set function, so regular functions. And up here we have a property, and inside the property itself has a get and set functions, which can also do some logic, so you can do some logic in between, or you can just return the underlying value. So basically using a property is pretty much the exact same thing as using a separate get and set function. Also, one more bonus thing, which is that C# is smart enough to automatically create the underlying field for a certain property. So if you just want to do a get and a set, then you don't need to define all this. You can just define a property, and then inside you can just do get and set. And there you go, this code here works the exact same thing as we had previously, which in turn is the exact same thing as all the code we have here with a getter and a setter function. So here it is, a valid functional C# property. Now I have to say that personally I very rarely use properties. In fact, the only place where I use them is over here on the singleton pattern. For everything else, I normally use regular fields with get and set functions. Personally, that's just the way that I like to code, but that's really just personal preference. So if you do like to use properties, then go ahead and use them. Anyway, so the reason why I like using a property specifically for the singleton pattern is because the implicit implementation allows you to do something really nice. Again, remember the goal with clean code. We want to minimize complexity, and the best way to do that is minimize access. Here, if we set this property and we set it as public, then that means that any other class can both get and set, so anyone else can have both read and write access. So we have the exact same problems that I warned you about when I spoke about why you should not make everything public. And of course, if we make this private, then at that point we kind of lose the purpose of our singleton since no one else will be able to access this. Basically, we want to be able to access this reference from classes outside of this one, we just don't want those classes to also have write access. Now thankfully, properties have an excellent thing, which is you can define accessors for here both the get and the set. So we can make the property itself public, which means by default both of these will be public, but then we can also add the accessor over here private, which in turn means that the get will be public, so any other class can get this, but private means that only this class can set it. This way we have the exact level of accessibility that we want. This is the reason why for this specific use case properties are very useful. With just this one line of code, we already have our instance with the perfect level of accessibility. So now that we have this field, to set it, let's make a simple awake. So let's go over here, private void awake, and on awake we just set instance equals this. However, remember that a key point of the singleton pattern is you only have a single instance of something. So in this case we should never have more than one player. If we do, then something went wrong. So we can add a nice safety feature here. Let's just check if instance, if it is not null, meaning it has already been set to something. If so, then that's an error, something bad happened. So let's do a debug.log error, because this should never happen. So let's say there is more than one player instance. This way we have a nice safety check just in case something goes wrong. Alright, so that's really it for the singleton pattern. We just define a property with a public get and a private set, and on awake we just set the instance. That's it. As you can see, it's super simple. And now for the really useful part. Over here on the selected counter visual, now we can access the singleton instance in a super easy way. Let's make a private void start, and on start we just access the player class, and from the class we can access the static instance, so we can access the singleton, and now we can listen to the onSelected counter event. And over here by default, Visual Studio gives this function the name of the event and also the property. This isn't a very descriptive name, so I like to rename this, so Control RR, and just rename the instance here. Instead of instance, let's rename it to player. Okay, great. So over here we can listen to this event. However, here is yet another extremely important thing. Note how I made this on start. That is very important. If you do this over here on awake instead of start, and over here on the player, you're also setting the instance on awake. If you do that, basically there is a chance that this code will run before this code. And if that happens, well then this one, the player instance, has not been set yet, so this will be null and it will throw a null reference exception. Now whether this happens or not is actually somewhat random. It depends on the order in which Unity decides to run both these scripts. If Unity decides to run the player first and this one second, if that happens then there's no problem, but if Unity decides to run this first and then this one, then we have a problem. Let me do a quick test and see if in my case it triggers that error. And yep, in my case it did trigger that error, so here we have a null reference exception, and yep, it is being fired on this line. Now, one solution to this problem is you can tell Unity specifically which order the script should run in. So you can go up here into Edit, then go into the project settings. Then on the left side, you've got something called the script execution order. And basically over here, you can set the order in which all of these scripts run. So if you were to make the player script run before the default time, that would make sure that even though both these scripts are on awake, this one would run before this one. So that would fix that problem. However, you should really only use this approach in the last case possible where there really is no other way. In this case, we do have another better way. Personally, I have a very simple rule that I like to follow that helps solve this issue. As you know, Unity has both an awake and a start. And all of the awakes on all the objects will all run before all of these starts. So the simple rule that I follow is that I use awake for the initialization of that script, and for any external reference, for that I use it on start. So in this case, for initializing the player and setting the instance, that relates to the initialization of the player, so let's do it on awake. Whereas over here on the visual, since here we're going to access the player, which is an external reference, for this one, instead of doing it on awake, let's do it on start. This way we are guaranteed to make sure that this instance has been set. Okay, so with all of that, here we have our instance, so that works great, and we have our event, so that's great. Then here we have our event, and inside we've got our event args, so we can go inside the event args object, and inside we have our selected counter. So all we need to do is just compare which counter this visual belongs to. So let's actually make a field up here. So as usual, let's make a serialized field of type clear counter. So we have this one, and before we go into the editor, just make sure it compiles. Let's comment this out. So now let's go back into the editor. And over here, let's drag the reference. But again, remember, we're working with a prefab. So let's click on open to go inside the prefab. And now whilst inside it, let's select the selected game object and just drag the clear counter reference. Okay, great. Let's go back outside and save the changes. All right. So now here in the code, it's actually very simple. So we just do an if the selected counter matches this clear counter. If so, then we want to show this visual. If not, we want to hide it. So let's also add a reference for that visual. So let's add another serialized field of type game object for the visual game object. Then back in the editor, again, let's go inside the prefab, and on the select, let's drag the child kitchen counter. So drag that one, that is the visual game object. Okay, let's go back, save, and back in the code here, let's make some simple show and hide functions. So private void show and a private void hide. And now on the show, just going to visual game object and call set active. So this enables or disables the game object. So for show, let's set it to true. And for hiding, let's set it back into false. Okay, so now it's super simple. If the selected counter is this counter, then let's show the visual. If it is not, then let's hide the visual. All right, that's it, super simple. Let's test. So here we are, and if I approach that counter, yep, there you go, look at that, the nice selected visual. And if I go into this one, yep, there you go, I can see it. All right, great. So here we added a really nice visual to our selected counter, and more importantly, we learned about the super useful singleton pattern, as well as learning about C# properties, and a very helpful rule for how to avoid code timing issues. So this was a really detailed, really important lecture. If you're feeling confused about anything, go ahead, watch it again, or just post a question in the comments and I'll do my best to help. So with all of this is all great. We have the selected counter and we can see which one is actually being selected. Then by pressing a button, we can actually interact with it. So I can move and interact with any of these counters. But right now, just interacting with them doesn't really do anything. So the next thing we need is to create some proper objects for all of our ingredients, so we can later pick them up and drop them on counters. So let's begin doing that in the next lecture.